And welcome back, students. As we dive into our next section about linked lists, today we're going to discuss that of the stack and queue data structures. This is going to be something that is kind of familiar with how we can implement using linked lists, but the concept of stack and queue we've kind of actually have been knowing now for a little bit. So let's actually take a look at that. So the first thing is, of course, of stacks. Now, if you remember, we have talked about stacks in the past. Well, a stack is simply just a data structure that removes items in the reverse of the order in which they were inserted. So a stack, therefore, is a last in, first out data structure. So the items are retrieved, therefore, in the opposite order in which they were placed into the stack. So if you insert 1, 2, and 3 into a stack and then remove them, they will come out in the order 3, 2, and finally 1. We discussed this concept of stacks all the way back in programming 2 when we discussed recursion, because recursion works the same way. It makes a stack, it puts item 1 on, it puts item 2, 3, etc. So it builds it up until it's like, oh, I figured out the last problem, now I got to work back down off that stack. So 3, 2, 1, all the way back down until there's nothing left. So a linked list that can insert and delete only the head of the list, when we first looked at linked lists, that's in fact a version of a stack. So this is one of those times when if you want to stack, a singly linked list could be your implementation. So there's this concept known as push and pop. All right. And in this, you can imagine that the stack data structure is like a stack of trays in a cafeteria. So we can push a new tray on top of the stack in order to make a new and taller stack. Alternatively, if we pop the topmost tray off the stack until there are no more trays to move. All right. So pushing, we're adding stuff on. Popping, we're taking stuff off. Now, a definition of a stack with a demo program is shown in our course materials that is based upon our linked list class from the beginning of this chapter. The add to start method has been renamed to push in order to use stack terminology. So instead of calling it add to start, we're calling it push. Similarly, the delete head node method has been renamed to pop and returns the string from the top of the stack. Although it's not shown within our definition of the class materials here, it's appropriate to add other methods to your linked list class, such as paint, clone, equals, or even convert it to a generic data type, just so you can kind of have some of those other tools and capabilities. But for the purpose of our demonstration of what we're going to do today, they're not necessarily needed. All right, the other structure we're looking at today is that of the queue data structure, which functions in some ways similar to that of the stack. But if remember, stack was first in, last out, well, this one is first in, first out. All right, so this is kind of like a queue. If, like, for example, if you're at a bank or you're just standing in line for something, like you're standing in the lunch line, well, the lunch trays might be using that push pop. You gotta wait your turn. Customers, add themselves at the back of the line and then they're served at the front line. Right, whoever's first in is going to be one getting the first bite to eat, or in this banking example, is going to be the first one to get to the transaction of money. Now, a queue can be implemented with a linked list. However, there's a caveat. A queue needs a pointer both at the head of the list and one at the tail, or the other end, of the linked list, because the action is taking place in both occasions, because you kind of have to keep track of both of them. Therefore, it's easier to remove a node from the head of a linked list than it is from the tail of a linked list, because you have to kind of keep track of all this stuff. So a simple implementation would simply just remove nodes from the head of the list, and we will add nodes to the tail end of the list, or the back of the queue. So the definition of a simple queue class and demo program that's based on a linked list is, of course, given again in the course materials. We have not made our queue class in this example a generic queue because, again, we want to try and keep it simple, but it's kind of routine that you could replace the data type string with the type parameter. So you can make it a generic queue. And just a kind of a reminder here, just before we move on, is that a queue is a first in, first out data structure. That means the data items removed from that queue are in the same order in which they were added to that queue. All right, so that's the end of the notes, kind of a shorter one today. So let's actually go over to Clips and take a look at the code. You can see we have our inner class node here. It's just a singly linked list. So a very simple implementation. Then, of course, we have our stack here. All right, and we set head to null. We have our push, which you remember is the old add to start method. We just renamed it because we want more convention with our idea of a stack. Then, of course, we have pop, which takes it out. You can see if the head is null, we're going to throw an illegal state exception. Otherwise, we're returning that item. And, of course, is empty. Then, of course, we actually run an example. You can see we're pushing items onto the stack. and we're going to print them out. So if I run this, all right, we pushed in Billy, Lou, and Polly, and you can see that they came out in the exact opposite order, right? Because remember, with a stack, it's first in, last out, or last in, first out. Now, if we look at the queue data structure, you can see it's very similar, except of course now we have two nodes. We have a front and a back that we're keeping track of, right? And we have the add to back method blank right now because you're actually going to do this in the self-test exercises. But this is what would actually add those nodes on the end. Because remember, we add it to the tail of the queue when we're dealing with a queue data structure. All right, and of course, then you got your is empty, you got your clear. We also have these methods, who is next, which simply returns a string in the front of the queue, and it's null if queue is empty. And this removes a string from the front of the queue, so remove front and returns if it's empty. So if we look at our demo, you can see we have our queue. We're adding to the back these three items. Then we're checking to see if it's empty. Otherwise, we're going to print out who's next. Then we're going to remove the front until the end when we're going to say the queue is empty. So we had this, of course, add to back method filled in because remember, you haven't done that yet. Then you would see that the list Tom, Dick, Harriet would print out Tom, Dick, Harriet because remember with the queue, it's whatever comes in first is going to be printed out first. If this was a stack, instead of being Tom, Dick, Harriet, it would be Harriet, Dick, Tom. But because it is a queue data structure, it's Tom, Dick, and then Harriet. All right. So that kind of wraps up this lesson, folks. Kind of a relatively simple thing, just one more thing that kind of shows an implementation of what we can use like linked list data structures for or other various structures. So with that being said, I will see you next time.